Hi, let's revise safe use of electricity. So this portion will look at what are some hazards when you use electricity and what are some of the safety features we can have to ensure that we can use electricity in a safe manner. So electricity is very useful, we all know that, but it also has some hazards, and sometimes it can even cause the loss of life. So some of the main hazards will be people getting electric shock, or what we call electrocuted, or it can also cause a fire. So electric fire is a common cause of fire. So what is the electric shock? Now, when electrical current flows through our body, like what you see this happening to this boy right now, then we say that you have an electric shock, because normally when we touch objects or we touch a conductor, no current will flow. So once electrical current flow through your body, you say that you are being electrocuted, or there is an electrical shock. A very small current is enough to kill you, right? And so why do we get electrical shock or electrical fire? Well, let's take a look at some of the causes. This is one of the main cause of electrical shock: damaged insulation. Our wires that we use at home has been insulated. So what is the meaning of insulation? Insulation means you add a layer of insulator so that the current cannot flow through the wires. So it can be some cloth-like material, or it can be rubber. So if you look at this wire over here, this part, let me change the ink. So this part is insulated, but you can see this part here is exposed. So this is what we call damaged insulation. Now this will be dangerous because there's no insulation. So if your finger were to touch this, and then you get electric shock. Okay. So it's important to ensure that your electrical appliance have the insulation that's intact and should not be damaged. And this is a very common thing that people do. They plug in a lot of socket. They plug in a lot of plug into the same socket. So when this happens, we call this overloading. That means you put many socket into one. You put many plugs into one socket, right? So when that happens, this socket actually becomes very hot, and then you may end up overheating, and then you get fire because it's so hot. So if you were to put many plugs into the same socket, when you switch it off, you notice that this part here is always very hot. Okay, so when it gets too hot, or the cable gets too hot, it can cause a fire. And this is what happens. Okay, when the cables get too hot, you get a fire, and then this is an electric fire, right? Every cable, these are what we call cable. Every cable, there is a certain maximum current that can flow through. Okay, so in this case, if you put in so many different plugs, then your multi-plug will have a large current flowing through it, and this will cause this cable to be very, very hot. Another way that we can get electric shock is what we call dam condition. Now, dam means there is water. So what happens is, because our body is an electrical conductor, and if your body is wet, we are an even better conductor. So if you use your wet hands to touch electrical appliance, then you are actually exposing yourself to the risk of electric shock. Because then when your hands are wet, okay, when your skin is wet, you find that when current flow, it will be a very large current. When your skin is dry, the current is smaller. So especially when your skin is wet and you touch, then you find that a large current will actually flow through your body, and you can get an electric shock. So never operate any electrical appliance with wet hands. This is what happened when you talk about loose connections. You look at this plug, probably done by someone that's not qualified. You look at this part here. Okay, a lot of loose wires, And so what happens is if you have a lot of loose connections, the current can sometimes form a spark and jump over to this side and jump over to this side. So then you see sparks inside, because when the connections are loose, then you get bare wires. So these are bare wires. Bare wires means that you are not insulating it. And then when the sparks form again, you can actually cause a fire. So make sure they are securely attached, and this can be done by getting a qualified electrician. So what we have gone through are all the different ways that different ways in which if you don't use electricity carefully, you can get electric shock or fire. So let's revise one more time. If your insulation is damaged, you can get electric shock. If you put in too many plugs in a socket, we call it overloading. It causes a lot of overheating, and then you can get a fire as well. And of course, if you use your hands, wet hands to operate electrical appliance, you can also get electric shock. If your connections are loose, you can actually form sparks, and then you get a fire. So how can we use electricity safely? Okay, so there are four things that we're going to talk about. A fuse is something that helps you to use a circuit in a safer manner. Circuit breaker, earth wire, and double insulating wire. So we'll look at each of these separately. So what is actually a fuse? Well, a fuse actually is just a cartridge, like what you see here, and there's a wire inside. So if the current is a normal current, okay, not too large, the current will just flow through, no issue. But if the current is very large, then it will make this wire melt. So when this wire melt, what happens is you get a circuit that is broken. Okay, so then in this case, you do not allow any more current to pass through. So you actually prevent um, overly large. Overly means much larger than what you would like to have flow through your circuit. Okay, it prevent overly large current from flowing into it. Okay, so when the current is too large, it will break. Now every fuse has what we call a fuse rating. So what is a fuse rating? For example, a fuse, okay, so for example, I have a fuse. There are different types of fuse rating. Say for example, if the fuse rating is 1 ampere, that means any current, the largest current that can pass through is 1 ampere. If you get, let's say, 1.1 ampere, then what happens is the circuit will be broken. Okay, then no, circuit broken, so I cannot have current anymore, sorry. The circuit will be broken. Okay, if you have smaller current, like say 0.9, 0.8, then no problem. Of course, there are different kinds of ratings. We can have, let's say, a rating. So if your fuse has a rating, let's look for a bigger one. Let's say some fuse have a big rating. So like, let's say 10 ampere. Then what it means is that 1 ampere, yes, it can pass through. 2 ampere, 5 ampere, 7, 9.9, 10. Anything that's more than 10, then you find that your circuit will be broken. Okay, so no more current can flow through. So that is the meaning of rating. That means the largest current that a fuse will allow to flow through. Anything larger, the wire inside will melt. So what is the correct fuse to use? Well, say for example, you have a rice cooker, and the rice cooker needs a current of 4 ampere in order to operate. Then you will choose a fuse that is slightly larger than 4, but not too large. So 5 will be a good option, but you wouldn't choose one that's much larger like 10. Neither will you choose, for example, 3, because 3 ampere means you won't even allow 3 ampere to pass through. So how can the rice cooker ever be used, right? So if I have, say, a heater, and this heater will operate, I will need 2 ampere. No, let's say I use, so let's say this heater um, is a large heater. So let's say it requires 8 ampere to work. So then MCQ choices, they will say which one would you choose as the rating? Is it 7? Is it 8? Is it 10? Or is it 15? Right? So what you do is because the current that's required for it to work is 8, we will choose one that is slightly larger than 8. So in this case, I will choose a 10 ampere fuse. I cannot choose 7 or 8 because 7 or 8 means that my current will never be able to go beyond 7 or go beyond 8. Then my water heater cannot use. I do not want to choose 15 as well because then I'm not protecting my appliance. Circuit breaker operates like a fuse. So this is very familiar in your house, right? Inside the storeroom, I think many of you will have a circuit breaker like that. So if any of the circuit has a current that's too large, then the circuit breaker will trip. So you need to reset it. Okay, you will push it up to reset it. So it works like a fuse, but a circuit breaker is reusable. So a fuse, right? Once the wire inside melt, then you cannot use anymore. Okay, but circuit breaker, you can actually reset it and you can use it again and again and again. Reusable. Next, earth wire. So what is the earth wire? Earth wire basically is something that prevents you from getting electric shock. And what you need to know is that earth wire is connected to the metal casing. So if you look here, so normally the current will come in, right? The current comes in, operates the water heater, goes out, and no issue. But if accidentally one of the wires were to touch the metal casing, I don't need earth wire if the casing is a plastic because I will never get electric shock if I touch a plastic casing. But if it is a metal casing, then I got to be careful because if accidentally one of the wires would, the live wire were to touch, then this whole thing becomes live. That means very high voltage. Then if someone were to accidentally touch it, this person gets electric shock, right? So what happens is to prevent that from happening, to prevent someone from getting electric shock when you touch a metal casing of a faulty equipment, so I will attach an earth wire. So you see, so now the current will flow to the earth. So there's an earth wire. So earth wire must be connected to metal casing. So it's important for you to know where you actually need to connect them. So earth wire, you connect to metal casing. One end is metal casing. The other end goes to the earth of the place. So what about the fuse? Well, for the fuse, you will always connect it to the live wire. The fuse is connected to the live wire. There are 3 wires, right? Live, neutral, earth. So the fuse connects to the live wire. Circuit breaker also. Earth wire will be one side. Earth wire, one side is to the metal casing, the other end goes down to the earth. And final safety precaution is double insulation. You see, what do I mean by double? This is one layer of insulation, right? So there are 3 wires, all 3 has been insulated, and then there's one more layer here to insulate it again. So this is a safety precaution, right? It's for safety because even if this layer of insulation were to wear out, there's another layer outside. Or if the outside one wears out, there's still one more layer inside, right? So safety precaution will be using double insulation, using earth wire, using a fuse to prevent too much current from entering the circuit, right? So that's all for this part.